welcome to our class today. And today I want us to be able to discuss about the network diagram. And I have a question here which we are going to be able to do the network diagram, whereby we have been given activity, we have also been given the preceded activity, and also the duration. Duration here, it can be in the number of days, so we can have the duration maybe in days here, sometimes it can be in weeks, but in this kind of particular case, I want the duration to be in terms of the days. So you have activity A, B, C, D, and the E, and then they are asked us to be able to draw a network diagram. So we want to be able to see how can we be able to draw that kind of particular network diagram. So in terms of drawing this kind of particular network diagram, we always start with the first node. We're going to start with that first node, which is node number 1. This is going to be the node number 1 that we should be able to start with. And then activity A, if you can be able to see activity A does not have a predecessor. An activity that does not have a predecessor should always start from node number 1. In this case, activity A is going to start from here to node number 2. So this activity A, and remember in a network diagram, an activity is always represented by an arrow. So this kind of particular arrow there. And then activity B is also going to start from node number 1, because also it does not have a predecessor. So activity B, that's node number 3. And I have said that an activity that does not have a predecessor is supposed to start from node number 1. From node number 1. So activity A and the B, they are going to start from that node number 1. And then let us go to activity C. How can we be able to draw this activity C? Activity C starts from where A ends. Where this A ends, that's where we are going to commence that activity C. And before we draw activity C, we need to be able to check whether C is a predecessor of another activity. And if you can be able to check this kind of particular C, you can be able to see C is a predecessor of activity E. The reason why we usually look ahead is to be able to know the direction of the network. The way we are going to have that direction of the network, so that we can be able to draw those activities that are going to end together by actually focusing ahead. So activity C is going to start from A, and we have seen that activity C is a predecessor of E. Then it means that before we start activity E, C and D must actually end together. So we must ensure that when we are going to draw activity E, C and D are supposed to end together, in the sense that we are supposed to have activity C and D ending together that way before you start activity E. Before you start that activity E. So that is what it means, that we have to ensure. That's why we have to focus ahead and see the direction of the network. So now, this is what we are going to do here. Activity C, we have seen that it is starting from A, and back in our mind we know that C and the D at the end of the day, they are supposed to be able to end together, as we are going to draw the other kind of particular activities. So activity C starts from A. It starts from A that way. And that is activity C starting from A, so where that A ends. And then activity D is supposed to start from B, where B ends. But again, we have to check this activity D, is it going to be a predecessor of another activity? Yes, it's going to be a predecessor of E, because you can see D here. So then that also reminds you again that activity C and D are supposed to end together for you to start E. So D is going to start from here, from where B ends, as the equation is actually saying. So it's going to start from here, and it will end with this kind of particular activity C. So that now C and the D can actually be able to end together the way the question is saying here. So now activity E is going to start from where C and the D ends. So we're going to draw our activity E. So this was node number 4. And then activity E, this is going to be node number 5. That's going to be the node number 5 there. So we were being given the duration. You can be able to see that we have for activity A, the duration is 5. For activity B, duration is 3. For activity C, duration is 10. And then for activity D, duration is 2. And then for activity E, duration is 6. So that's the duration that we have actually been given there. So we have been given the duration of those kind of particular activities. So the number of days that they are going to take for you to complete those kind of particular activities. Now, we are done with the first part, which was drawing a network diagram. And that's how we usually draw that kind of a network diagram. So now, we want to be able to determine the critical path. This critical path. So the critical path is always the longest path in a network diagram. They can ask you that kind of particular question in an exam. Define the following terms as used in a network diagram. And they can ask you the critical path. And we have said that the critical path is the longest path in a network diagram. And how do we get the critical path? That's the question that we should ask ourselves. How can we be able to get that critical path? So for us to be able to find the critical path, we must first of all find what we call the earliest start time. The earliest start time, which sometimes we call the forward pass. So we must find that earliest start time, which is also known as the forward pass, because we are going to move forward so that we can be able to find that kind of particular critical path. And this kind of particular circle, when you have been given this node or a circle, the upper quadrant, this upper quadrant that you see here, usually represents the latest completion time. The latest completion time. And the lower quadrant usually represents the earliest start time. So the latest completion time is going to tell us the latest time that we are actually going to be able to take to complete that kind of particular project. Remember, the network diagram is always used in project planning so that we can be able to know when are we going to complete that project and when should we start the particular project. The lower quadrant here represents the earliest start time. When should we be able to start our project? So this is what it actually represents there. So now, in terms of finding the earliest start time, I want us to start with the earliest start time, which I've said that earliest start time, which is also known as the forward pass, is going to be given by this kind of particular formula. So we take the earliest start time of starting activity. So it should be, I should start with the maximum of, so it should be the maximum of, into bracket, earliest start time of starting activity plus duration. That's how you get the forward pass or the earliest start time. Maximum of earliest start time of starting activity plus the duration. And the earliest start time in node number 1 is always 0. It's always 0. That is always 0. The earliest start time under that kind of particular node number 1 will always be that kind of particular 0. And then now, the other thing that we are going to be able to get, we are going to move to node number 2 and then find the earliest start time here. So for us to be able to move from node number 1 to 2, we only need one direction, that's 1 to 2. So it's going to be 0 plus 5, which is going to be 5 here. So we're going to have our 5 there. That is 0 plus 5, which is actually the earliest start time of starting activity, which is 0, plus the duration. And the duration is this 5. So it's 0 plus 5 as per that kind of particular formula there. So 0 plus 5, and then you get 5. So you move to node number 3. For us to move to node number 3, we only move from 1 to 3. So it's going to be the earliest start time of starting activity, which is 0, plus the duration, which is 3. So which is 0 plus 3, which is going to give you 3 there, which is going to give you 3. And then the other thing is we move to node number 4. So for us to move to node number 4, that's where now we are going to use this wording that is here, the maximum of. So for us to be able to arrive at node number 4, we can either move from 2 to 4 or 3 to 4. If we are going to move from 2 to 4, the earliest start time of starting activity under node 2 is actually now 5. So it's this 5 plus the duration, which is 10. So it's going to be 5 plus 10, which is 15. So 5 plus 10, which is going to be 15. So let me put 15 somewhere here. Because here we have 2 directions, so that's why I'm not indicating it, and we are supposed to take the maximum of. Again, to node number 4 is going to be, if I move from to node number 4, I can move from 3 to 4 there, which is now going to be the earliest start time of starting activity, which is 3, plus the duration, which is 2. So it's going to be 3 plus that kind of particular 2 there, so which is going to give you 5. So 3 plus 2, which is 5. So now we take the maximum of. So when we have more than 2 directions to arrive at a particular kind of particular node, we are going to use the maximum of when we are computing the forward pass, or what we call the earliest start time. So then it means that we are going to take 15, which is the maximum. We always take the maximum. That's why we have maximum of into bracket earliest start time of starting activity plus duration. So to node number 5, we only need one direction, that's 4 to 5. And the earliest start time of the starting activity is this 15 plus this kind of particular 6. So it's going to be 15 plus 6, which is going to give us 21. So we're going to take our 21 there. So by us doing that way, we are done with computing the earliest start time, or what we call the forward pass. That's what we call the forward pass. So now, we want to be able to get the backward pass. We are going to be able to find the backward pass. And how can we be able to find the backward pass? So for us to find the backward pass, this is what we are going to do here. If we want to find the backward pass, this is what we are going to do. And this is the formula that we are going to be able to use. So backward pass is finding actually the latest completion time, the upper quadrant here. And the latest completion time, when we want to get the latest completion time, we are going to take the minimum of into bracket the latest completion time of ending activity. The latest completion time of ending activity minus duration. So that's how we find that one. Latest completion time, minimum of, into bracket, latest completion time of ending activity, and then we subtract that kind of particular duration. So now, let us find that latest completion time. So now, this is what you need to be able to know. In the last node, the earliest start time, which is 21, is always equal to the latest completion time. So then it means we are going to have 21 here, and And also our latest completion time is also going to be 21. Our latest completion time is going to be 21. So now let us move backward, because it's now a backward pass. That's why the other name of the latest completion time is what we call the backward pass. So we are moving backward. So for us to be able to have the backward pass, we are going to take the latest completion time of ending activity, which is 21, and then we subtract the duration. And the duration there you can see is 6. So it's going to be 21 minus 6, which is going to be 15. Which is going to be 15 in that manner. So we have moved from node number 5 to 4. We are moving backward. That's why it is known as the backward pass. That's why it is actually known as the backward pass. So then let us move now to node number 3. So for us to be able to move to node number 3, we just need one direction, and that is going to be 4 to 3. And if you move from node number 4 to 3, it's just that 15 minus 2. 15 minus 2, that's the latest completion time of ending activity, which is 15, minus the duration, which is 2. And that is going to be 13. So that's going to be 13 there. And then to node number 2. Node number 2, we are going to take the latest completion time of ending activity, which is 15, minus the duration, which is 10. So it's going to be 15 minus 10, which is actually 5, which is 5 there. And then we move to node number 1. So we want to be able to see this kind of particular node number 1. And in node number 1 here, we need 2 directions. Now that's why we are going to use the word minimum of. So we are going to take the minimum amount. Now when you have 2 directions under the latest completion time, you are going to take the one that is minimum. But if it was to be the forward pass, then we take the maximum when you are faced with the 2 directions there. So now, for us to be able to move to node number 1, we need 2. We can make either move from 2 to 1 or 3 to 1. And if we are going to move from 2 to 1, it's going to be 5, which is the latest completion time of ending activity, minus the duration, which is 5. So then that kind of particular answer is going to be 0. So you can put 0 somewhere. And then if we can move from 3 to 1, it's going to be that 13 minus 3, which is 10. So in this case, we take the minimum of, and the minimum is actually 0. And in a network diagram, when you come from, you get when you are finding that kind of particular, the backward pass, at the end of the day, is supposed to be 0, 0. That's when you will be able to know that you are going to have the right answer. So that's how you find the latest completion time and also the earliest start time. That's how we find it. Those are the formulas that we usually use in terms of finding that kind of particular earliest start time and also the latest completion time. So now the question was, we determine the critical path. So the critical path is whereby the earliest start time is always equal to the latest completion time. Like the critical path from 1 to 2, that's a critical path. 1 to 2 because we have 0, 0, 5, 5. But 1 to 3 is not a critical path because here we have 13 and the 3, they are not equal. So the critical path is going to be that path whereby the earliest start time is equal to the latest completion time. Like here we have 0, 0, we have 5, 5. And then 2 to 4 is also a critical path because you can say we have 15, 15. And 4 to 5 is also a critical path because you see we have 21, 21. So our critical path then is going to be 1 to 2. So you just state it as 1 to 2. And then 2 to 4. And then 4 to 5. So that's how you find the critical path. That's how we are going to find that critical path. 1 to 2, 2 to 4, and then 4 to 5. And then the other thing that they want us to be able to find is the project duration. And remember, our duration was in terms of days. So how can we be able to find the project duration? So for us to find the project duration is actually from the critical path. You pick the duration that is along the critical path. So 1 to 2 was actually 5, so it's going to be 5, and then you add 2 to 4, which is actually duration is 10, and then you add 4 to 5, which is actually 6. So is that 15 plus 6, which is going to be 21 days. So that is the project duration. So that's how we find that kind of particular critical path and the project duration. So that's how we do it. That's how we do it. And I'm going to give you the other kind of particular videos on the same network. So that is the start of the network diagram. We will keep on doing more network diagram until you have a proper kind of particular understanding. So thank you.